Hi, my name is Hunter Long, and I'm going to be talking about my AMP Lab project. The title of my project is Facilitated Echolocation. Now, I want to start out by letting y'all see how I got started with this idea. I started working on the project over winter break, actually, and I got the idea slightly before winter break. And since I had a lot of free time over break, I decided to start trying to make some things. Here's the first experiment I set up in my the hallway in my house. So pretty much, you can see I have those two TV trays. It was a very professional setup. But all I was doing is I had these cheap computer speakers set up, and I had some microphones that I had soldered together and glued together. And I was pretty much just trying to send out pulses of sound and listening for the echoes. So I would send out a pulse of sound with the computer speakers and then record the echoes coming back and then slow down that recording and listen to it in slow motion. So when I got back to school, I started trying to work on my project through the AMP Lab here at Virginia Tech. And this was a really great opportunity because I feel like it probably would have never gotten any farther than that setup I had in my hallway if it hadn't been for the AMP Lab. I started meeting with Bob every week, and we kind of worked out the details as to what kind of equipment I needed to continue, and also what sort of steps were the next to take in my project. So here you can see kind of, this is a little preamp board I started out with. And here is one of the newer microphone elements I got. This one is a lot better than the initial ones I started out with. The initial ones were just some little condenser microphones that I hot glued onto a pair of earbuds. And they worked fine, but they didn't have a very high frequency response, so I couldn't slow down the sound that much and listen to high frequency sounds. And this is showing some of the really cool stuff that I was able to acquire through the AMP Lab. You can see this is an amplifier, and it's an audio amplifier that we purchased, and it's pretty powerful. You know, it can output all the power that I need, and it can go up to about 70 kilohertz or so, which is plenty high enough for the experiments that I'm conducting, because I want to generate a sound that's around 30 kilohertz or 25 kilohertz. And what I wanted to accomplish with my project is to give people the ability to echolocate similar to the way that bats or different kind of animals already do. And so to do that, there's a lot of equipment that I'm trying to use to enhance the natural ability people have to hear and their limited ability to generate sound. So the basic setup here on this cart here is, you see this is just an arbitrary waveform generator, and that is connected to this amplifier down here. And this is pretty much, it's almost the same as a normal stereo amplifier you would listen to music on. But the good thing about this amplifier is that it can generate sounds that are in the ultrasonic frequency range, where most amplifiers aren't able to do that. And we tested it out and made sure that it would be able to drive these specific types of transducers. What I have here is a piezoelectric transducer, and you can see it's horn-shaped, and that acts as a waveguide that focuses the sound this direction. And they're very good for producing sounds that are in the upper limit of your hearing, like in the upper audio range into the ultrasonic frequency range. So the sounds I was planning on generating were around 25 or 30 kilohertz, and these will do a great job of reproducing those sounds. And they're very efficient too at transferring the electrical energy into sound energy. So you can see this is connected to this amplifier. So whatever type of waveform I generate with this function generator is amplified by the amplifier and then transmitted out of this horn here. And I put it on this mic stand so it's easy to move around and aim at different places. Now, that is only half of the echolocation system, because these three things allow us to generate any type of pulse we want. So with a bat, the bat makes a call, but that's only half of it. It listens to the returning echoes, and based on those echoes, the time and different characteristics of them, that's how it determines what is surrounding it, like the different objects that are surrounding it. So to record these ultrasonic pulses, they're not even audible with your normal hearing. You can kind of hear them, but very faintly. So what we have here is just some pair of little microphones. These microphones are nice because they will pick up frequencies up to around 50 or 60 kilohertz, which is higher than what we need. So they will accurately reproduce the sounds that are 25 or 30 kilohertz. And this little board is just providing a DC bias for them, and they are fed through this cable into this USB sound card. And this sound card is nice because it can record up to 192 kilosamples per second, and that allows us to have enough samples per second to actually record ultrasonic sounds, where most sound cards that record at a lower sampling rate wouldn't be able to pick up these ultrasonic sounds. So after these microphones record the sound, after these microphones pick up the sound, it's recorded by a computer connected to this USB sound card. And then once it's recorded, you can do all kinds of things with it on the computer. So the thing that I'm trying to do is just basically reduce the playback speed. So I'll record it at 192 kilosamples per second. But when I'm playing it back, I'll play it back at 10 times slower or 20 times slower. And what that does, it does two things. It allows you to hear the very small time difference between the outgoing pulse and the echoes returning. And it also down converts the frequencies you can't normally hear, which are 25 or 30 kilohertz, to a frequency that your ear can easily hear. Maybe down convert it to 2 kilohertz, which is easily heard by your ear. So this is the basic setup of my experiment, and it's really nice because it's very flexible, and you can adjust the waveforms that we're generating for the outgoing pulse, and because it's recorded on the computer, it's very easy to do different types of signal processing on the recorded data. So this has been a very good setup for learning more about echolocation and the type of things I wanted to investigate initially. So right here are the two microphone elements that I've been using for my testing. You can see these little gold pieces right here are the actual microphone, and then they're connected to the sound card through this cable. So what I want to do is a quick demonstration. I'm just going to hang these right here best I can, just to keep them in place. Now, what I'm going to do is I've got the function generator on, and it's set to generate a burst, and it generates one burst of 30 kilohertz sound every fifth of a second, and it only makes 15 cycles of that 30 kilohertz tone every fifth of a second. So you'll hear it. You can actually hear it clicking, kind of. It's like click, 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 and that is the sound cutting on and off. You can actually hear that. So what I'm going to do is cut on this, and this will the amplifier will generate a signal that will make sound come out of this piezo tweeter, and then I'm going to stand over here, and as I walk towards it, the echoes reflecting off of me should be picked up by this microphone, and so Dennis is going to record it, and we'll let you listen to it back. So when we tried playing back the sound that was echoed off my shirt, we couldn't really hear anything. So we're going to try it again using, I'm going to hold this this trash can. It's a nice solid trash can, a nice flat surface. We're going to see if we get some better echoes than the front of my shirt. So I'm going to go and cut this back on. You can hear that clicking again. And I'll get the trash can ready. And then you tell me when.
3, 2, 1, go.
So we recorded those sounds with the computer using this nice software I downloaded, and you can see this is the Fourier transform of the sound. You can see the different pulses. So what I'm going to do is play it back, and I've got it set to play back at 1/20th the original speed. So you'll hear it, that 30 kilohertz will be down converted to 1.5 kilohertz, and also the time between the pulses, instead of being a tenth of a second like I had it, it'll be 20 times larger than that. So here we go, let's listen to it and see if we can hear the echoes. You can hear the two pulses. And as I got closer, the time difference between those two should be getting shorter and shorter. And you can kind of hear that as they're getting closer. See, now they're pretty much right on top of each other. It's hard to tell the difference.
So what did you expect from the Amp Lab when you started this project?
Well, when I was in high school, I always loved experimenting with electronics things, and my dad and I, we got like a little workbench set up in our basement, and we would always go in there and love taking things apart and just playing around, making different electronic things. And I thought when I went to college, I'd be able to continue that and really be able to expand on that. But it kind of turned out when I got to college, I got so busy, and there wasn't really any place for me to work on the things. Like at home, I had my basement with all this junk in it where I could just play around with things. But here at college, I just had my dorm room, and I couldn't, do any soldering or any kind of cool projects in there. So I was actually really excited when I heard about the Amp Lab, because that's what I've been looking for. Now I'm in my third year of college, and I've been looking for something like that, and I was so happy when I heard about it. And so what I expected from the Amp Lab is, first off, just a place where I could work on things, where I could solder, and secondly, also a place where I could get some just like mentorship with learning how to do things, because I'm not that experienced with electronics, and I'm trying to learn, but a lot of times it's helpful to have someone there to kind of guide you and point out if you're doing something wrong, or give you good advice about how to do something. So those things are really what I wanted to get from the Amp Lab, and I feel like I've definitely gotten both of those things, and also just the ability to have all this really nice equipment that I would never have been able to procure on my own. It's just made it a whole lot easier to do testing, and it's just given me the ability to pick something that I'm kind of interested in and have all these resources available where I can investigate it and just do research on my own. So.